Exercise 5. In the demo help files in Excel, you'll see that exercise 5 has 36 steps to follow to complete this exercise. First, we will open MedSmart, click OK on the welcome screen, and then study the exercise. In this exercise, a survey of your screen has been done to check its performance. We have to enter the data into MedSmart, mass balance it, and construct a curve to diagnose any issues. Specifically, we want to know the bypass, the D50C cut size, and the efficiency of the separation. So I double-click on the icon, click the welcome message, and now we have our software open. Next step is to drag a feed belt icon to the flowsheet, and then drag a scalping screen icon to the flowsheet, connecting the two. So feed belt, drag and drop, scalping screen, drag and drop. Click once on the feed belt, go to the product board, click, hold and drag to the entry port on the screen. The screen and the feed belt are now connected. Next, click on the settings button in the top ribbon and click on the click to enter sieve sizes section. So settings, click to enter sieve sizes. Here we have to enter the sieve sizes that we will use. G9 says open the exercise 5 file in Excel and copy the sieve sizes from Excel into the software, and then click accept to close the window. So in the folder MedSmart training data, there is a section called Excel files and exercise 5 screens. Here we can see a feed, oversize and undersize information. You have to select the sieve sizes, say Ctrl C, press Ctrl C. Go back to the software, click on the first line in the sizes. It will turn blue, and press Ctrl V. Close that and click accept. Here it is a good idea to save. The next step is to enter your survey data and then excluding assays from the calculation. I will click on Enter Survey Data and then go to the Assays section and exclude the assays because no assays were taken in the survey. In the Survey Rates tab, we have to enter the information from the Excel sheets for exercise 5. That's the SG, the feed rate, and the accuracy. SG was 3, the feed rate was 10, and the accuracy is 10. It's 10 for a very accurate number. Next, we will click on the Survey Percent Solids tab. And here we will enter the percent solids and accuracy information from the Excel sheet for this exercise. Feed is 92%, oversize is 99%, and the undersize is 80%. Feed 92%, accuracy of 10 because it's feed. Oversize is 99%, accuracy of 7 because it was a measurement. Undersize is 80%, accuracy of 7. Next, we will click on the Survey Size Distributions tab and enter the sizing data and accuracies. We have to copy and paste from Excel into the software table. After that, we will click Accept to accept the data and close the window. Survey Size Distributions. In exercise 5, we can copy and paste the size distributions into the software. So I'm copying all 3 columns at the same time. In the software, I click on the top left corner, it will turn blue, and I will click Ctrl V at the same time. Here, my feed belt product is very accurate, so the accuracy is 10. My oversize was measured, so it's 7. My undersize was measured, so it's 7. Now I click Accept to accept this data. Back to the demo help files. Now we're at G20. Click the Mass Balance button to start the mass balance, click OK on the message box, and then view the mass balance results by clicking at the mass balance results icon. So click on mass balance. My mass balance is complete. Click on mass balance results and view the mass balance in table and graph formats. This completes the mass balance section, and now we can move on to the calibration section. G25 says click the Survey Equipment Data button in the top ribbon. Then we will open exercise 5 file in Excel and enter the data for the screen into the table. After this, we will click Accept to close the screen. So click on Survey Equipment Data, go to the screen and enter the data. The opening size was 3 mm. So it's a fine screen. Click Accept. The survey data has now been entered. Click the Calibrate button in the top ribbon. This will calibrate the model, so it will model fit parameters to the data. Then we will view the calibration results in the top ribbon. Specifically the calibration constant results. Calibrate. Calibration results. This is the calibration stream results. Calibration constant results gives us the sharpness of the cut, the D50C, and the water split to the undersize. This means what percentage of fines in the feed will go to the undersize. So this means 3.7% of the fines leave with the oversize. This would have gone red if this would have been a problem. So these conditions are actually quite good. This graph, size distributions, shows us the accuracy of the model fit. Between these lines we can see it's quite close. Next is calibration curves. This is the efficiency curve and information about your screen. You can use this graph to diagnose potential issues by doing regular surveys. So we click the size distribution graph, the calibration graphs, and we can close the calibration results and the demo. So the purpose of this exercise is to demonstrate that you can enter survey data to diagnose specific issues that you might not be able to see with the eye, or that you might not be able to measure on the plant.